All right, let's jump right in. Today, we're going to break down the clinical pathway for rickets, a condition that, and I mean this quite literally, helps shape a childhood.
You know, to really get to the heart of what rickets is, we have to start with a pretty basic question. What actually happens when a child's bones, the very framework that's supposed to be holding them up as they grow, just fail to harden properly? It turns out that one single problem is the root of everything we're about to talk about.
And this right here is the perfect place to start, because it shows the first crucial distinction. See, it's all about timing. When this failure to harden bone happens in a kid before their growth plates have fused shut, we call it rickets. Now, if the exact same problem happens in an adult after those growth plates are closed, we call it osteomalacia. But for our purposes today, we are laser focused on the growing skeleton.
So let's get a really clear picture of what rickets actually is. The best way to think about it is as a major failure in the body's construction project.
I love this analogy. Imagine you're building a skyscraper. The body puts up this flexible, organic framework for bone. That's the osteoid. It's kind of like the steel rebar. But then the concrete, which in this case is minerals like calcium and phosphate, it just never arrives. So you have this frame, but it has no rigidity, no strength. And when a child puts weight on it, it bends. So here's the official clinical definition. Rickets is a metabolic bone disease in kids. And the key phrase, the one to really remember, is poor mineralization. And it's happening specifically at the growth plates while the child is still growing. That is the absolute core of the problem.
Okay, so that's the what. We know it's a failure to build. But why does it happen? Well, it turns out it's a delicate chemical balance that gets thrown completely out of whack, starting a serious chain reaction.
You see, our bodies are in this constant, carefully controlled dance of vitamins, hormones, and minerals to keep our bones healthy. But in rickets, something interrupts that dance, and it kicks off a cascade of problems.
Now, this is where it gets really interesting. This slide maps out that whole chain reaction beautifully. It all starts with a trigger, usually not enough vitamin D. That means the body can't absorb calcium from food. So what happens? Step 2, the body panics and releases something called parathyroid hormone, or PTH, which basically has one job: get calcium no matter where it has to find it. And the consequence of that, step 3, is that the body starts pulling calcium directly out of the bones themselves, the exact opposite of what you want. And finally, that leads to structural failure. The unmineralized parts of the growth plates get wider, they get weaker, and they start to bend under pressure.
So what causes that first domino to fall? Well, it pretty much falls into two main buckets. By far, and I mean by far, the most common cause is nutritional rickets. It's a simple deficiency, not enough vitamin D from sunlight or diet. Then you have the much rarer genetic forms, where a kid has a mutation that stops their body from using vitamin D properly, even if they have plenty of it.
And for that super common nutritional type, there is a very clear danger zone. We see it most often in kids between 6 months and 3 years old. Why? Because this is a time of incredibly fast growth. Their bodies are just screaming for building materials like calcium, which makes them way more vulnerable if there's a shortage.
Okay, so that brings us to the next big question. You have this invisible chemical mess going on inside the body, so how do doctors actually figure it out? Well, they learn to read the body's signals, which can actually become pretty clear.
As the disease progresses, the signs really start to show up. A clinician will look for things like a soft skull, or bumps along the ribs that they call a rachitic rosary. And of course, the most famous sign of all, the bowing of the long bones in the legs as they literally bend under the child's own weight.
But to really confirm it, they need to look inside. And that's where X-rays are absolutely essential. They're looking for what's called the diagnostic triad right at the growth plates. First, there's fraying, where the end of the bone looks all blurry instead of having a nice sharp line. Then there's splaying, where it widens out. And finally, cupping, where the end of the bone actually becomes concave, shaped like a little cup.
And this is the real aha moment, the key connection. That bowing of the legs that a parent might see on the outside is a direct physical result of that weak, frayed, and cupped bone structure that the doctor sees on the X-ray inside. One causes the other.
So once that diagnosis is confirmed, the story completely changes. It becomes one of hope. And that's because treatment for rickets works really well. It's not a one-size-fits-all guess. It's about finding a specific fix for a very specific problem.
And this slide just lays it out perfectly. That whole diagnostic journey we just walked through lets doctors map the exact cause to a targeted treatment. If it's simple nutritional rickets, the fix might be as simple as vitamin D and calcium supplements. But for those rare and complex genetic types, like vitamin D-resistant or dependent rickets, you need a totally different playbook. Sometimes that means phosphate replacement or even using really advanced therapies to correct the specific broken pathway.
So, let's wrap this all up. What are the big takeaways here? First, rickets is a failure to mineralize the bones of growing children. That's key. Second, it's usually kicked off by a simple vitamin D deficiency that starts a nasty domino effect. Third, the diagnosis is just this fantastic piece of clinical detective work, connecting the signs you can see on the outside to the evidence on an X-ray. And finally, and this is the best part, treatment works so well because it's precisely targeted to whatever started the problem in the first place.
And that kind of leaves us with one last big thought. We understand the science, we have the solutions, and yet the most common form of this disease is totally preventable. It really makes you wonder, doesn't it? Knowing that the foundation for a lifetime of skeletal health is built in these first few years, are we really doing enough to make sure every kid gets that strong start?